Okay, so again, 4-2 trigonometric functions, the unit circle, we're going to break this down. But like I said, by tomorrow, you guys are going to need to know those 30, 60, 90, 45, 45. Remember them from when you used them initially. If you don't, you need to keep working at it. Because the longer it takes you to remember those, the harder everything else is going to be. Because in trig, everything links to the thing before it. So none of it goes away. So just so you're aware. Okay, so we have the unit circle. It's called the unit circle because it has a radius of what? This is the center. The origin's the center. What is the radius of that circle?
I don't know.
Well, look at the circle. 1.
2.
It's 1. How do you know it's 1?
Because it's from the middle to the...
I was
Middle
thinking
to
of
the-
diameter. Because it's the middle to the one of the sides.
The point on the circumference of the circle is what? 1. So the radius is 1. Okay, so from the center of the circle, which is at the origin, to the circumference of the circle, it is 1. It is 1, 0, 0, negative, 0, 1, negative 1, 0, and 0, negative 1 because it's a coordinate plane, correct? Now, when we think of the unit circle, the equation for a circle is, any circle is x squared plus y squared equals r squared, okay? Any circle, that is the equation. But if my radius is 1, 1 squared is what? 1. The unit circle is kind of a special thing. It's actually, how do I want to say it? It's the ratio circle. It's the circle of ratios, okay? So when we are going to put our 30, 60, 90, 45, 45, 90 triangles in there. But what is the hypotenuse of both of those? It's 2, right? Mm-hmm. Yeah? Okay, so technically our ratio is 2, but when it reduces down, we get these. So the unit circle is 1 unit out, and so we can remember those points where it hits. Okay, so we have 6 trig functions: sine, cosecant, cosine, secant, tangent, and cotangent. You have been exposed to sine, cosine, and tangent before in geometry. We abbreviate these. Sine, and it's of an angle. We use theta typically. It could be any variable, okay? Sine is a function, okay? Cosine of theta. Again, cosine is a function. Those are not two separate things. So we say cosine of theta, sine of theta. Tangent, we say tangent, we write TAN of theta. The word is sine, cosine, tangent. You are not going to say tan, sin, cos. No. I won't listen to you. I won't acknowledge that you even spoke.
Oh.
It is sine, cosine, and tangent. CJ, put your mask.
So do you want us to worry about the cosecant?
Yep, I'm getting there. Okay, cosecant is CSC. Secant is just SEC. And cotangent so those are the 6 trig functions. When you look at your learning goals, it says the 6 trig functions, and that's what you're using. Okay? They are paired the way they are because these two are reciprocals of each other. These two are reciprocals of each other. and these two are reciprocals of each other. When I ask for things on a test, the order I will ask them in is sine, cosine, tangent, cosecant, secant, cotangent. I write them like this every single time. Because sine and cosecant are reciprocals of each other. So if I know one of them, do I know the other one?
Yeah.
Yes. Okay, so what happens is I tell you only worry about the sine, cosine, and tangent. And then remember that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. So I go from having to remember 6 things to down to what? 3. And then that these are reciprocals. Okay? So in here, I will be always telling you ways that you can remember one thing by linking it to another. Yes?
Okay, that's kind of weird because it's like sine goes with cosecant and cosine goes with secant, but tangent goes with cotangent.
Right.
That's stupid.
I didn't name them. Sine and cosine are co-functions of each other.
Duh.
And what that means is if two functions are co-functions of each other, that's why it's sine and cosine, that the sine of 60 is the cosine of 30. What's so special about 60 and 30? What do they add up to?
They double.
90.
They add up to be 90.
Oh.
Okay? So co-functions have the same values. So the secant of 75 is equal to the cosecant of 15. Because 15 and 75 equal 90. That is why, I mean, that's their co-functions. I don't know why they came up with the names that they grouped them with or anything like that. Tangent and cotangent have the same. If you worry, most people struggle with secant and cosecant. Remember that your pair has to start with an S and a C. Do you see that? If you paired an S and an S together or a C and a C together, you did it wrong. That was the only thing that kind of helped me. And we will, if you do your assignments, you will do them enough you won't forget it. Okay, so we're going to learn, there's like 3 different definitions of sine, cosine, and sine, cosine, tangent, secant, cosecant, cotangent that we're going to learn. The first one we're going to start with is in a coordinate plane on that unit circle, okay? So we're going to think of them as x's and y's. Okay? So when you have a point, now this is the very basic way, there's really not a whole lot of depth we can go with this, and it is one of my least favorites because I can't adapt it to anything else and use it. Okay? It's usually one I spend a little teeny bit of time on and we never use again. Okay. Sine of t is just a variable. If you want to put theta, you can put theta, but don't put x. Why don't put x?
Because you use x.
We're terms in x and y, right? I don't like to use t, but the book loves t, so. Sine of t equals the y coordinate. That's what it equals. Cosine of t equals the x coordinate. Tangent of t equals y over x. And why can't x be 0?
Because you can't have a fraction with 0 as the denominator.
Right, because you can't divide by 0, it's undefined, right? So anytime you have a fractional thing, they're going to tell you it can't be whatever, right? Okay, they've paired sine and cosecant because those are those co-functions, right? And they're reciprocals. So if sine is y, cosecant is 1 over y. And why can't it be y be 0? Because you can't what? Can't divide by 0. So you have an undefined spot there. So we have an asymptote in the cosecant graph. So it's undefined, right? Linking you back to chapter 2. Cosine is x. Well, secant is the reciprocal of x, which would be what? 1 over x.
Did
And-
it stop recording?
No.
Oh, 'cause it just got a little-
No, 1 over x. And x can't be 0 because we can't divide by 0. Okay, tangent and cotangent are reciprocals of each other. Tangent is y over x, so cotangent is x over y. Now, Shelby, in physics, you did SOHCAHTOA, right?
Yeah.
Okay, we will get there. And it's basically SOHCAHTOA, just different variables. It actually is SOHCAHTOA, different variables. And you only use sine, cosine, and tangent, correct?
Yes.
Okay. So that is what we're using just today. Your assignment is very, very short. 4 problems. Okay? But you're going to do the 6 trig functions of every single problem. When you write them, I suggest you write sine of t or sine of whatever the angle they give you equals x, and then write your answer. Cosine, I said that wrong. Sine of t equals y, then your answer. Cosine of t equals x, then your answer.
We're gonna have to remember all this.
Yes, that's why I'm telling you to write it every single time you do it today. If I'm giving you only 4 problems, I'm expecting you to do them and learn them. Tomorrow when you walk in, you should be able to tell me these. Okay? You should be able to tell me the tangent is y over x. Yes?
So with the t, is it fine if we can put theta?
Yeah.
in it?
You can put theta, you can put anything. It's just a variable, don't use y or x.
Okay.
Okay, so guys, I never remember cosecant. I never say, oh, cosecant is this. I say cosecant is sine, sine is y, so cosecant is 1 over y. Do you see what I just did? Do not sit there and focus on those bottom 3. You need to focus on the top 3 and know which one's the reciprocal. So cosine is x. Well, secant is the reciprocal of that, so it's 1 over x. I'm always linking it back. So let's use it in the way you're going to use it in your assignment. Okay, find the exact value of the 6 trig functions for the real number of t for the given point. That's what it says in the book. That's exactly the directions in the book. They have a picture. Well, this is in the unit circle. The implication of this is it's in the unit circle. So I'm going to make my circle first. Here's my unit circle. I have negative 3/5, comma 4/5. What quadrant is negative x, positive y? 1, 2, 3, or 4.
I'm trying to think of it.
It'd be
Negative
3,
x.
wouldn't it?
Negative x,
Third.
positive y
Oh,
would
the
be
second.
quadrant 2. It's just the axis, yes, where that coordinate would land. So somewhere over here, right? Some angle like this. This point right here is here. This is x, this is y, yes? So, sine of theta, and I'm going to use theta because I like theta. I don't like t, but it says t, so use t, whatever. I will try to use the variable that they give me. No, I'm going to erase. I'm going to use the variable that they're going to give me because I expect you to do it. And I don't like t's, and I don't know why I don't like t's. I don't like i's either. Okay, another thing is I typically put parentheses around it because that tells me the of. Does that make sense? It's sine of t, and it will help you know what you're taking the sine of, because we'll add other things to it. So sine of t is, what is my variable for? No, what is my variable for sine? Y. Every problem you're going to write that, because tomorrow, if I ask you, here's a scratch piece of paper, or here's a quiz, 20-point quiz, write those 6 things down. You need to be able to do it. That's how important it is, guys. Okay, sine is y. What is the y? 4/5. Cosine of t is x is negative 3/5. Tangent of t, what over what?
X over y. Y over x.
Y over x. y over x. So we're gonna have y over x, so we'd have 4/5. I should not be doing this down this low. 4/5 divided by negative 3/5. Okay, when I divide fractions, I multiply by their reciprocal, yes? So it's gonna be 4/5 times negative 5/3. What's gonna happen to my 5s?
Reduce.
Reduce to 1. And my answer is just negative 4/3. Now, what do you notice? This is 4/5 over 3/5. My 5 got cut off. My denominators are the same, yes? Every time your denominators are the same like that, are they going to reduce out? Every time.
Yeah.
Yes. So it's basically just numerator over numerator, only if the denominators are the same, correct? Okay, definitely should not have put these on the same slide, huh? Okay, so what do we got? What goes with sine? What's the
One
reciprocal?
over-
What is that?
See it?
Cosecant of t.
Yeah.
So sine is y, so
It's 1 over
cosecant
y.
is 1 over y. And so we should get the reciprocal, yes?
4/5.
It's just the reciprocal, so it's 5/4?
Do the same thing.
Yes. 1 over 4/5, okay. Now you said 1 over 4/5, but then I have to multiply by the reciprocal
okay.
4/5, right? So it's 5/4. I showed you that once, you'll never have to do it again, right? You just reciprocate it every time. What is the reciprocal of cosine?
Secant.
Secant.
Negative 5/3.
So what's your ratio? 1 over x. So negative 5/3. Cotangent, that goes with what? Tangent. So it's the reciprocal of tangent, so it's x over y. Now,
Can we just use a simplified version?
we're gonna go through it again. We're gonna go through it again. When we come out, it should be negative 3/4, yes? After we do our math, it should be negative 3/4, but we're gonna do the math again. Today, do the math. After today, you should be fine not to have to do the math again. Got it? Okay, so we have x, which is negative, I'm gonna do it up here, negative 3/5 divided by 4/5. So I'm gonna multiply by the reciprocal, right? 5s are gonna reduce, and I'm left with what?
Negative 3/4.
Negative 3/4.
Crazy.
Okay, so do the math today, because that's math we're gonna do a lot, and you need to be okay with doing it and not struggling over it. Does that make sense? Especially when you know the answer, just do it, so you can check it. Now, write down these, and I will add a slide, because I didn't give myself enough room. So write those two, write the next point down.
Would we be able to reduce it before we do anything?
Yeah,
Okay. Oh.
which I should have done. I think I was just grasping at numbers, didn't even think about it. You guys have got it written down? Okay. So it was 24/26
Yeah, negative 10, 26.
and negative 10/26.
Do you simple or like put them to the?
Yeah, we can simplify them.
That'd be in the fourth quadrant.
Okay, you want to simplify them first?
Yes.
So 12 over 13 and negative 5 over 13. Now, you noticing you can do that is a good thing because you're going to have to reduce it regardless anyway. And that's actually one of the special triples, Pythagorean triples, 5, 12, 13. Happens all the time. Okay, so what quadrant is that?
Fourth,
Fourth. Why?
because it's positive x and negative y.
It's a positive x and a negative y, so it's somewhere down here.
And it's V.
Oops, that's not how we draw an angle. Is it? Okay, so it's here, yes?
Do we write V1? Yeah.
Do I write what?
VI.
Oh, if you want the quadrant to remember, it would be Q what?
1V.
1v.
Oh, 1V.
Yeah, if you want to do that so you remember, practice that, sure. Because I'm sure that's going to be one of those easy questions, those gimme questions on the test that we want to do. And you are going to have to identify like which quadrant sign is positive in and cosine's negative in, things like that. So writing that is not going to hurt me. The more I can do to show my work and my thought process, the better foundation I'm going to have to build off in trig. Honestly, guys. And the sooner you learn something, the better. Yes?
How did you know it was a 4?
Because the x is positive and the y is negative, so the positive x-axis and the negative y-axis, so that puts me in fourth quadrant. So sine of t, what's my ratio for t or sine? Y. So my answer is
12 over 13. No, negative 5 over 13.
negative 5 over 13. Cosine of t, what's my ratio?
X.
And x is
12 over 13.
12 over 13. Tangent,
X over Y. No, Y over X.
y over x. Now, we're tempted to say x over y because we usually do x over y, right?
Yeah.
Remember this, tangent is related to slope. You don't know how yet, but it is. How is slope? It's the change of y over the change of x, yes? Okay, so just in your brains, right now, make the connection between tangent and slope. Got it? That will help you remember y over x. So,
Negative 15 for
negative 5 over 13, right? Over 12 over 13. Now I know these 13s are going to reduce, yes?
Yep.
So my answer is going to be
Negative 5 12.
negative 5 twelfths. See how I still showed it and then reduced it? Okay? I'm still showing the math. How did they reduce? Because I multiplied by the what? Reciprocal. Okay, so what function is the reciprocal of sine? Cosecant. You're getting there. Okay, so the reciprocal of y is
Negative.
1 over y. Not negative. Well, yeah, but
Sorry.
yep, you were skipping. Okay, so it's just the reciprocal. So the reciprocal of negative 5/13 is negative 13 fifths. Now that negative doesn't matter whether it's with the numerator or denominator, does it? When we actually start drawing triangles, because what we will do is sit here and draw this right triangle, and we will do things with it, we will talk about the parts of this, and we can have a negative y, we can have a negative x, but can I have a negative hypotenuse? No, because a hypotenuse shows a distance. Okay, so then it will matter who, like which value gets the negative, but right now it doesn't. Okay, so what's the reciprocal of cosine?
Secant.
Secant. So the secant is what?
1
1
over
over
X.
X.
1 over x. So my value is
13 over
13 over 12. Cotangent is the reciprocal of
12. Of tangent.
a tangent, so it is
X over Y.
x over y. And so it's 12 thirteenths over negative 5 thirteenths. So it is negative 12 fifths. Okay. Questions? See, this is the good thing about this recording now. All I have to do is reconnect. It doesn't stop it. Okay, so I think we might have one more, we might not. Let me check. If we have one more, I want you to do it on your own. Yes. Well, I've got 2 more. What quadrant is the first one in?
The third.
The third, because both x and y are negative, yes? Okay. The second one, what is it in?
Quadrant 1.
Quadrant 1, because they're both positive. See that? Okay. Now, I do this first one on your own, The second one we will do together. What's a little bit different about the second one?
It's got a square.
It's got a square root in it. So we'll do that second one on our own. On our own. Do the first one on your own, and then we'll go do the second one.
Does it say where we draw our angle in quadrant 3?
No. Just put it in quadrant 3. It's just important that I know it's in quadrant 3. They always tend to be like right in the middle of the quadrant for me. If we knew an angle, then it would, but since we don't know an angle. Do you all have the point written down that I can add a new slide and write down the second point already? Okay. And the picture, guys, is just for you to get a reference so you can start seeing how things are working, okay? Because if we can visualize something, we can usually do it better.
Did you reduce? Oh, wait, no.
Yep. Don't I have to reduce?
Yeah.
Yep. I always have to reduce. Now, I didn't reduce at the beginning, which would have made my life easier. Who reduced at the beginning?
I did.
Made your life easier, didn't it?
Yeah.
Because I was like, oh crap, I gotta reduce. So if you can reduce, reduce. The only time I wouldn't reduce is if like the x reduced and the y didn't. Because I want to keep those common denominators, don't I? So, I mean, you'd obviously have to reduce at the end of them, but I wouldn't reduce at the beginning.
I started doing the sign, but then I was like, oh, well, I 15, so then I just erased it.
And just did it. Yeah. Okay, how did it go?
Good.
Great?
Easy.
No.
Easy dog.
Any, no one's at no, right?
I just
Let's
didn't
see your
reduce
thumbs.
it, but other than that.
You gotta dial.
Got a big curve bump.
Can you draw the? Oh, you did draw the picture.
I did draw.
Oh, I put my line the wrong way.
Then it always looks weird.
Which line?
Like the.
This is straight.
Oh, the angle?
Yeah.
Yeah,
I
because
put it in the third, but I put it down.
okay, it doesn't tell me whether it's a positive or negative angle, does it? No. But I just assume that it's positive because it's just easier that way. But it doesn't matter because it doesn't say it's a positive or negative angle. Because if it was positive or negative, they would still have the same. There's coterminal. Okay, this is why, guys, coterminal are awesome. Because whether that's a positive angle, which would be over 180, wouldn't it? or a negative angle, which wouldn't be, could be over 90 but not 180, they have the same sine, cosine, tangent, secant,
So it
cosecant,
doesn't matter.
cotangent. It doesn't matter because they are a coterminal angle, and every time I go around the circle and land right at that angle, whatever it is, positive or negatively, those are going to be the answers. Okay, so next one, we said it was in the what quadrant?
No, we didn't discuss
First.
this
We haven't.
I know, we haven't. We're doing it right now. So it's right here, yes?
Yeah,
This is X and this is Y.
yeah.
Okay, so there's a square root in there, so I'm probably gonna have to do some rationalizing. A little bit, maybe. Okay, so
Since they're both positive, like,
sine of
this
t
is like X and that's Y. So it's just like you're graphing.
Equals Y,
equals Y,
which is 9/10.
so it's 9/10. Did anyone do sine and then do cosecant right away?
I thought about it anyway.
Did it?
but I
Sometimes I do that, sometimes I don't. But I always do them like they're always on my paper, like side by side like that. I never, the book will sometimes put them in a list. I'm
I
like,
thought
that's
they were
gross.
like this, and then whatever.
Yeah, I like columns. Okay, cosine is what?
X.
So it is,
Square root of 19 over 10.
now I'm gonna tell you that this is kind of giving you a very basic view of what we're going to be doing, guys. This is kind of why I don't like it, because it really generalizes it a lot. Okay, tangent,
Y over X.
I think I did this one right.
so we have 9/10 over square root of 19/10. So I'm going, and I'm gonna go down. So I'm gonna have 9 over the square root of 19, yes?
You can't have that.
I can't have that, so I have to multiply by
Square root of 19.
square root of 19,
Your answer
the
is
square root of
Y.
19.
Square root of 19.
So your answer is 9 square root of 19
Over 19.
over 19. And if I could reduce the 9 and the 19, I would from there, correct?
Yes.
Okay, so you are going to have to do that sometimes when they just give you a point. Okay, what's next?
What happened to the 10? Did it
The
just
10s and the
drop?
10s reduce, because when I multiply by the reciprocal, as long as it's 10 and 10, it's always going to reduce. Okay, what's next? Cosecant, good job. We didn't stutter on that one this time. Cosecant of t is what?
1 over y.
1 over y. So we get the reciprocal of y, which
10
is
over 9.
10 over 9. Now you noticed I didn't look at sine, did I? I went back to my original. Why didn't I look at sine? What happens if I accidentally like wrote 8 over 10? I'd get it wrong, right? So for a while, let's make sure we're always referring back to the original, because we don't want to get one thing wrong and get them all because of it, do we? Okay, and then secant is what?
1 over x.
1 over x. So back to x, I get
10 over 9.
10 over the square root of 19,
Which you can't do.
which we can't do. So can we do this in our head this time?
Yes.
It's going to be
10
10.
square root of 19 over 9.
over 19. Now, when I made you start doing that earlier in the year, you never thought you could do that in your head, did you? See, you grew this much. Okay, cotangent is what? X over y. Now, this is why I don't come back to tangent definitely, because if I reciprocate my tangent now, I got to rationalize again, don't I? If I go back to my points over there, I have the square root of 19 over 10 over 9 over 10. So when I reciprocate, the 10s are going to reduce, right? And I just have the square root of 19 over
Wait a
9.
dang minute.
That's
I got a
actually kind
question.
of easy.
Yes.
On secant,
Yes.
why is it 10 to the 9 and square root of 19?
Because I had to multiply.
What? I thought you just reciprocated. So what did we?
No.
What did I do over 10?
I had to multiply by the square root of 19 and the square root of 19. I reciprocated x, that. I reciprocated x and got 10 over the square root of 19. then I have to rationalize. So multiply by the square root of 19, square root of 19. I can't leave a square root in the denominator. Now, my old book did in their answer key. I will not accept it. Understood? I don't know if this one does. If you get an answer key that had 10 over the square root of 19, that is wrong in my book. It's not correct. It's just like not reducing. So rationalize it and make sure you have it. Don't say, well, the book didn't rationalize it. I just told you all right now, didn't I? You have to rationalize every time it's a final answer. Do I have to rationalize like in the middle if I don't want to? No. But if it is a final answer, you have to rationalize. Got it? That is it for today. Do I have any questions? Okay. So